Welcome to my video lecture based on electric circuit theory. Paper code PCEE 301. Today's topic is interrelationship between two-port network. Myself, Gungun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrashur Institute of Technology and Sports Complex. Today, we will learn about the third lecture of two-port network. In my previous lecture, we have discussed about what is two-port network, what are the types of two-port network, and then we have discussed about reciprocity and symmetry condition for two-port network. In this lecture, we will mainly learn about the interrelationship between two-port network. That means the relationship between Z parameter with Y parameters, or Z parameter with ABCD parameters, or ABCD parameter with Y parameters. This kind of relationship we will see through this lecture. So let us start with the interrelationship between two-port network. Now we will see that how this interrelationship can be built in case of two-port network. Each type of two-port parameter has its own utility and is suited for certain specific application. However, it is sometimes necessary to convert one set of parameters to another. It is possible through simple mathematical manipulations to convert one set to any of the remaining sets. It is discussed as below. So, we can see that Z parameters in terms of all other parameters and how this relationship can be built, that we will see. And based on this type of calculation, you can easily perform the relationship between other parameters also. So here we will mainly highlight about Z parameters in terms of other parameters. And I will tell you that you just do your own hand calculations for other parameters in a similar way, and you just match it with the results, that actual result is coming on that. So, Z parameter in terms of Y parameter. We know that the Z parameter equations are V1 equals to Z11I1 plus Z12I2. This is the first equation for Z parameters, this one. And V2 equals to Z21I1 plus Z22I2. This is the second equation of Z parameter. Now we will write the equation for Y parameters, and that is I1 equals to Y11V1 plus Y12V2, and I2 equals to Y21V1 plus Y22V2. So from the equation, we can write that V2 equals to I2 by Y22 minus Y21 by Y22 into V1. We have used this relation. This is 7.16. We have used this relation for doing these calculations. Now, we will put this value of V2 in the equation 1 of Y parameters, this equation. So, we have write I1 equals to Y11 V1 plus Y12, and in place of V2 we have put this relation. And we have got that V1 equals to y22 by del y into I1 minus y12 divided by del y into I2, where del y equals to y11 into y22 minus y12 into y21. Substituting this value, our second equation, we are getting that I2 equals to y21 into y22 by del y into I1 minus y12 by del y into I2 plus y22 into V2, or V2 equals to this one, that is minus y21 by del y into I1 plus y11 into del y into I2. So comparing these equations with the z parameters equation, we have got that z11 equals to y22 by del y and z12 equals to minus y12 by del y. We have just compared this equation with the z parameters equation of V2. So we have got z21 equals to minus y21 by del y and z22 equals to y11 by del y. Okay. And for comparing the values of z1 and z2, we have used this relation. So in that way, we have got the relationship between z parameters in terms of y parameters. Similar calculation we will do for ABCD parameter also. So the transmission parameter equation, first we will write, that is V1 equals to A into V2 minus B into I2, and I1 equals to C into V2 minus D into I2. So from the second equation of this one, again C into V2 minus D into I2, we have used this relation. This is 7.19. And now we will separate the V2, and we have got that V2 equals to 1 by C into I1 plus D by C into I2. Similar way, we will put the value of V2 in the equation A into V2 minus D into I2 here. We have put the value of V2, and we got that V1 equals to A by C into I1 plus AD minus BC by C into I2. So again we will compare this equation of V1 and V2 with Z parameters equation of V1 and V2, and we have got that Z11 equals to A by C and Z12 equals to AD minus BC by C, and Z21 equals to 1 by C and Z22 equals to D by C. All these relations we have got from comparing this equation with Z parameters equation. Now in terms of hybrid parameters, so first we have write the equation for hybrid parameters, and that is V1 equals to H11 I1 plus H12 V2, and I2 equals to H21 I1 plus H22 V2. From second equation, that is V2 equals to minus H21 by H22 into I1 plus 1 by H22 into I2. We have put this relation in the first equation, and we have put this value of V2 in first equation, and we have got that V1 equals to H11 I1 plus H12 into minus H21 by H22 into I1 plus 1 by H22 into I2. So again we have got the relationship of V1 and V2, and again we have compared this relationship with the relationship of Z parameters, and we have got that Z11 equals to H11 H22 minus H12 into H21 by H22, and H12 equals to H12 by H22, and Z21 equals to minus H21 by H22, and Z22 equals to 1 by H22. Similarly, the interrelationship of the other parameter in terms of remaining parameters is obtained by writing the remaining parameter equations in the same format as those of the other parameters and comparing the coefficient of the two sets of equations. A relation is obtained. A summary of the relationships between impedance Z parameter, admittance Y parameters, and hybrid H parameters and ABCD transmission parameters are showing in the next table, and that we will see. This is the interrelationship between all two-port networks. Here, this is the relationship of Z parameters with Y parameter, with ABCD parameter, with H parameter. This is Y parameter with Z parameter relation, Y parameter with ABCD parameter relation, Y parameter with H parameter relation. This is Z parameter with ABCD parameter relation, ABCD parameter and Y parameter relation, ABCD and H parameter relation. This is for H parameter and Z parameter, H parameter with Y parameter, H parameter with ABCD parameter, and these two I am ignoring, this one and this one, because these two are not included in knockout syllabus. I am just ignoring this one and this one because these two are not included in knockout syllabus, so I am just ignoring this two. Now let us consider two problems related to Z parameter and Y parameters. We have taken one network and we have to find that Z parameters and Y parameters. So we have applied KVL in this figure. We can see that here I1 current is flowing and this current is divided into two branches, I3 and here I1 minus I3. Next this current comes here and again divided into I2 minus 2I1 minus I3 because the current is here 3I1. So it is I2 minus 3I1 here and I2 current is coming from this part. So we can write that V2 equals to 2I2 minus 4I1 minus 2I3 and V1 equals to I3 and 2I1 minus 2I3 plus 2I2 minus 4I1 minus 2I3 minus I3 equals to 0. And from there we have calculated that I3 equals to 2 by 5 into I2 minus I1. So from equation 1 we can write that V1 equals to minus 2 by 5 into I1 plus 2 by 5 into I2, that is minus 0.4 I1 into plus 0.4 I2. And from equation 2 we can write that V2 equals to 2I2 minus 4I1 minus 4 by 5 I2 into plus 4 by 5 I1. So from these relations we can write that Z equals to minus Z11 equals to minus 0.4, Z12 equals to 0.4, Z21 equals to minus 3.2 and Z22 equals to 1.2 ohm, where del Z equals to minus 0.4 into 1.2 minus 0 into 0.4 into 3 into 2, that is 0.8. And y equals to, that is 1.5 minus 0.54 minus 0.5. So from z to y we have directly used the relationship of y to z to y calculation, and we have made this y matrix. Let us consider another problem. The y parameter for a two-port network N are given as y11 equals to 4 ohm, y22 equals to 5 ohm, y12 and y21 equals to 4 mho. All these are mho, not ohm. This will be only mho because these are y parameters, these are admittance. If a resistor of 1 ohm is connected across port 1, here, this is port 1 and 1 ohm resistance is connected here, then find out the output impedances. Output impedance is given as Z out equals to Z11 Z22 minus Z12 into Z21 divided by Z11 plus ZL. Now here Y11 equals to 4 mho, Y12 and Y21 equals to 4 mho, and Y22 equals to 5 mho. So using the relationship of Z parameter with Y parameter, that is Z11 equals to Y22 by del Y, and we have putted all this value and we have got that Z11 equals to 5 by 4 ohm. Similar thing we have used for Z12 and Z21, and we can write that relation directly, that is Z12 by Z21 equals to minus Y12 by del Y. So the value we are getting that minus 1 ohm, and Z22 equals to Y11 by del Y equals to 1 ohm, 4 by 4, that is 1 ohm. So putting these values, we can write that Z out equals to Z11 into Z22 minus Z12 into Z21 divided by Z11 plus ZL. So ultimately the value of Z output we have got, that is 5 by 9 ohm. And we have used the direct relations here for calculating all these Z parameter values, and Y parameter values are given here in this problem, and we have just using the relationship with Z parameter and Y parameter, and we have directly put it here for calculation purpose. Now next problem let us consider, that is find the equivalent pi network for the T network shown in figure. We have to find out the pi network of this given problem A, and find out the given T network for pi network as shown. And for this one we have to find pi networks. Let us see how this can be possible. Let the equivalent pi network of have YC as the series admittance and YA, YB are the shunt admittance at port A and port B respectively. That means just we have taken the circuit of pi network and we are considering the admittance as YA, YB and YC. Now Z parameters are given as Z11 equals to ZA plus ZC, this one ZA and this one ZC, and Z1 to Z21 equals to ZC, that is 5 ohm, and Z22 equals to ZB plus ZC. ZB plus ZC. Okay. And del Z equals to Z11 into Z22 minus Z12 into Z21. So we have got that del Z value is 27.5. Now we have again used the direct relationship of Y and Z, that is Y11 equals to Z22 by del Z, and we have outputted the value. Secondly, Y12 equals to Y21, that is minus ZC by del Z, that is minus 5 by 27.5, and Y22 equals to Z11 by del Z, that is 7 by 27.5 more, and YA, YB and YC values we have calculated by using this relation. And this is the relationship where we can convert the T parameter into pi network, T network into pi network, and using that relation we have directly converted this one. Thus the equivalent impedance for pi network are Z equals to 1 by YA, ZB equals to 1 by YB, and ZC equals to 1 by YC. In that way, we have converted these values to pi network, and all these values I have put it, and this is the pi equivalent of that network, which is given in T form. Now, we have to convert the pi network into T network. Second problem. The Y parameters are here. Y11 equals to 1.2 mho, Y21 equals to minus 1 mho, and Y22 equals to 1.5 mho, and del Y equals to 0.8 that we have calculated. Okay. This one. Now we have directly taken the relationship of Y and Z, and we have all calculated all the values of Z11, Z12, Z22, Z21, all these values we have calculated. Now from there, we have just calculated the value of ZA, ZB and ZC to form the equivalent T network. And we know that ZA equals to Z11 minus Z12, ZB equals to Z22 minus Z12, and ZC equals to Z12. And we have converted the pi network to equivalent T network. Now to find the equivalent T network, we have the relations. That is Z11 equals to ZA plus ZC, Z12 equals to Z21 equals to ZC, and Z22 equals to ZB plus ZC. So using these relations, we have got that ZA equals to 5 ohm, ZB equals to 15 ohm, and ZC equals to 5 ohm. These three things we have calculated using this Z parameters. So up to this is for today's lecture. In this lecture, I have discussed Z parameters, how to take the relationship Z parameters with all other parameters, and I will definitely tell you that you just practice other parameters conversion relation with your own hand, like from Y parameters to Z parameter conversion, or ABCD parameters to H parameter conversion. That things you have to practice with your own hand. When you practice with your own hand calculation, you will got the confidence that you can solve those problems easily, and that conversion is not difficult. That conversion is very easy. You have to just compare the relations, that it is in I1, I2 form or V1, V2 form. Whatever the form is, we have to just putting the values in the other equation, and then we will compare it with the original equations, and in that way we can calculate this value. So for this lecture, I have taken with help of Abhijit Chakraborty book of circuit theory. Here several types of numerical problems are solved in this book. I will definitely prefer this book for your understanding purpose, and definitely you must go through that book, and also you can take the help of Surajit Bakshi book of psychic theory. That is also a good book, and D.Y. Chaudhary book is also there, but numerous problems related to circuit theory is solved in Abhijit Chakraborty book. And for electrical engineers, definitely I will prefer that book of Abhijit Chakraborty of circuit theory for your understanding and calculation purpose. So definitely go through that book and practice inherent problems which is already solved in the book, and all the other problems which is in the exercise part that you can try to solve, and that will help you to understand the psychic theory problems. So thank you all. Thank you all for listening my lecture. And in my next lecture, we will again continue with two-port network. Thank you.